In this video, we will learn how to write an assembly language program to multiply 16-bit number. So in this program, we have started with that dot model small. So small is used for taking the data segment and code segment within only one program code segment. And here we have declared this dot data for declaration of our data variable. Here we have to perform the multiplication of 16-bit number. So for declaration of 16-bit number, we are using DW directive. So DW stands for define word. Number 1 and number 2 are declared as a 16-bit number. We are taking the value of number 1 is equal to 1200 and value of number 2 is equal to 2000. We can take it as the number that is 0200. Okay. So now next one, in that code segment, we are taking here the value that is move ax at the rate data and move ds comma ax. So this two line of statement that is used for initializing the values of data segment into our code segment. So whatever the value you have declared within your data segment, that we can use in our code segment. And we can access the variable that are used in our data segment. So these three lines are written for actual our multiplication of 16-bit number program code. So the first of all, we have to copy the contents of number 1 and number 2 in our 16-bit register. So first of all, we are copying the contents of number 1 into our AX register and then contents of number 2 into our BX register. So value of our number 1 is equal to 1200. So we are copying here the value that is 1200 in our AX register. So the contents of 12 will be stored in our AH register and the contents of 00 will be stored in our AL register. Now the second statement is move BX comma number 2. The contents of number 2 is 0200 and that we are copying it into our BX register. So our BH will store the value that is 02 and our BL will store the value that is 00. So this is our BX register. Now the next statement is mul BX. So this is our actual multiplication of our two register, that we are performing the multiplication of AX into BX. So first of all, we have to check in our multiplication instruction what is the unsigned 16-bit source number is given in that mul instruction. So in our mul instruction, we have written here BX. So BX is our unsigned 16-bit source. Whenever we are writing here mul BX and our multiplication is for 16-bit number, that time we are multiplying it here, that is AX into unsigned 16-bit source. And we are putting here the value that is AX is equal to AX into BX. So we are declaring it as DX colon AX. So why we are writing here DX into DX colon AX? Because after multiplication, if number exceeds than 16-bit number, that time we are storing the value into our DX colon AX. That is the higher bit of 4 digits will be stored in our DX variable and the lower bit of our 4 digits will be stored in our AX variable. So see here the value of AX is equal to 1200 and value of BX is equal to 0200. So after multiplication, this value becomes 240000. So this is our result. And when we are considering this result and we have to store this result into our DX colon AX variable. So how this data will be stored it into the DX colon AX? So the first, this lower nibble will be stored into our AX register, and the upper part of our result, that is 0024, will be stored in our DX register. So that is the concept of our DX colon AX. So the first higher nibble will be stored in our DX register, and the last lower part of our nibble will be stored in our AX registers. So after multiplication 1200 and 0200, our result will be 0024 and 0000. So these bits will be stored it as 0024 in our DX register and 0000 in our AX register. So in case of 16-bit multiplication of program, our result will be stored in DX colon AX is equal to AX into unsigned 16-bit source. So you have to remember this operation, that is multiplication of the 16-bit number. So now we will check this contents in our emulator screen. So check these contents in our emulator screen. We have started the execution of our program, and we are in the line number move ax at the red data and move ds comma ax. So here we are copying the address of our data segment into our ax register and the values of ax into our data segment. So check that the contents of data segments becomes 0710. Now the next line is we are copying the contents of number 1 into our AX register after writing the statement move AX comma number 1. So check that our now AX becomes 1200 because value of our number 1 is equal to 1200. Now we are copying the values of number 2 into our BX register. So see here the value of bx will be updated and it will become 0200. And after multiplication of mul bx, we are multiplying this as ax into bx, and the result will be stored in our dx colon ax register. So I am clicking on that single step mode of execution and our result will be updated. That is our dx consists of 0024 and our ax consists of 0000. So now we are at the line of move age, comma 4ch and integer 21h. So these two lines are used for ending our program and terminating our program. So we have to call this DOS interrupt, that is 4ch, and we have to copy the contents of our DOS interrupt into our AH register. And then our program will be terminated with the help of this integer 21h software interrupt.